Live. And we are live. It is Thursday, August 6th, 2015, 11 a.m. Pacific. And this is DB Hangouts. Today we're going to be talking about Orchestrator and Binlog Servers. Shlomi's gracefully put together a little presentation and demo so that we can see how all this stuff kind of works together, some cool things with it, and also heckle him while he's doing it, since he likes to kill -9 production machines during presentations. And then after that, we are kind of a little more open-ended, but we can start talking about configuration versus orchestration. So this is something that came up during the last conversation, and just maybe tools that people use and how people kind of manage that. So let's do a quick round of introductions. My name is Jeffrey Anderson. I'm a DBA at Box. And how about we go to you, Daniel?
Hi, I'm Daniel. I'm a DBA at Booking.com.
Okay, Morgan?
Morgan Tucker, MySQL Community Manager at Oracle.
And Shlomi.
Hi, I'm Shlomi, engineer with Booking.com.
Okay, so I guess without further ado, Shlomi, if you want to take it away and get us going.
Okay, cool. So the discussion today is about Binlog servers in general and recent developments with regard to Orchestrator and Binlog servers. So raise your hand if you've been to Jean-Francois's talk about Binlog servers during Booking Live, or you've read about it, or you know what this is about. Yay! Cool. Let me share my screen. See if that works out. Is that okay? Can you see my screen? Like a bunch of blue boxes, orange boxes. Cool. So this is a semi-production topology, which is anonymous. We're showing here a master, a bunch of replicas, slaves, and slaves of slaves, and a few of these are actually Binlog servers. So I'm going to show a bit visually what Binlog servers are, what they do, and what fun we can do with them, and how far we've progressed so far, because the solution is still not complete. And actually one of the most interesting problems is the migration, the state of transfer from a non-Binlog server topology to a full Binlog server topology, and the transition in between, where part of your topology is with Binlog servers, is actually quite interesting. So basically it looks like we have a master, a slave, 4 slaves for that slave, a bunch of slaves here, and another one here. And if you look a little more closely, you will see that most of the topology uses statement-based replication, but 3 slaves are like inherit, right? And these are actually the Binlog servers. Now, since I've anonymized this will be your only hint that these are actually Binlog servers. So it looks like just normal replicating slaves, but in fact, Binlog servers are something, a completely different beast. So it looks like a duck, it walks like a duck, it, I don't know, squawks, what's the word? Like a duck, but it's not a duck. A Binlog server is a masquerade. It's like MySQL in disguise, or a proxy to a MySQL, or what have you. It looks like a MySQL slave to its master. It looks like a master to any slaves replicating from Binlog servers. There aren't any in this topology right now, but we will have some soon. So if I'm replicating from Binlog server, it looks just like a normal MySQL master. If this Binlog server is replicating from this normal MySQL, that normal MySQL thinks that's a slave. I can actually connect to a Binlog server using MySQL protocol and do stuff like show slave status. But there isn't really MySQL behind this. That is, there is no data. In particular, the entire purpose of a Binlog server in terms of operation is to copy and paste the binary logs from its master and serve them to its slave, and to actually masquerade as the master to the slave. What do I mean? I'm going a bit fuzzy here. So let's put a couple slaves beneath one of those binlog servers. I'm going to take that slave and throw it on top of that binlog server. And I'm going to take that slave as well, put it on top of the same binlog server. And I've rearranged the topology. Hey, that's Orchestrator, rearranging through drag and drop. I've rearranged the topology such that I have like a normal master, a normal slave, a couple binlog servers, and a couple slaves replicating from the binlog server. So what's going on right now? Those slaves are connecting to the binlog server using standard MySQL protocol and are saying, you know, we want to replicate. Please give us your binary logs. And the binlog server connects to that master and says, well, I'm a slave. I want you to provide me with binary logs. And that much is not very different from a normal MySQL. However, the binlog servers take an interesting approach that they masquerade to these slaves as though they were that master. When these slaves connect to that binlog server, it says, yeah, my host name is actually that, and my server ID is actually that. And if you want my binary logs, well, I'm going to copy-paste them to you as if I'm that master. So for all purposes, these slaves actually think they're replicating from this server. Well, you do change master2 on these slaves to the host name or what have you of the binlog server, but for all purposes, it's just as if they were replicating from that master. That's a bit in technical terms. Now, what's the purpose? Why do we need all that? So one of the nice things here is that the binlog servers, these two and the master, are all equal. In what sense? I can take that slave and tell it and ask it to replicate not from the binlog server but from that intermediate master here. And the only thing I need to do for that to happen is to stop slave, change master to master host. That's whatever host name that is. But I'm keeping the same binlog file and the same binlog position. So I don't need to do fancy calculations, you know, where was I in the relay log, or where was my master in relay log or in binary logs as compared to its own master, and do all that math. The master and the binlog server are all doing the same binary logs at the same file names, the same numbers, the same positions. Failing over a dead binlog server, so if that binlog server right now dies, is very simple. I can take that slave and either repoint it to the master using the same binlog coordinates, or I could point it to any of its sibling binlog servers using the same coordinates again. So I only need to change the master host. And that is pretty cool stuff. For example, our setup at Booking is that right now we're using, there I go again with two slaves of that binlog servers. We're actually not replicating from any specific binlog servers. So we're using binlog servers quite a lot in production right now. We're using some topologies with some hundreds of machines. And one of the nice things that binlog servers provide us with is master fan out, right? Instead of throwing 100 slaves under one single master, we're using a bunch of binlog servers, and those binlog servers replicate from the master. There's just like 3 or 4 of them, that's all. And then they can relay to dozens and dozens and dozens of other slaves. So those slaves don't actually replicate specifically or explicitly from the binlog hostname. What we're using is that we use right now a floating IP like a VIP. It's actually a DNS entry, and the DNS serves the binlog service on a round robin basis. So the slave connects to I don't know, my topology -vip .booking.com, and whichever binlog server is served by the DNS, that's fine. It doesn't matter. I can connect to this one or to that one. It doesn't matter. If that one fails, the slave doesn't need to know anything. The DBA doesn't need to know anything. No one needs to know anything. The slave will fail. It will implicitly try to reconnect to its master. It will ask the DNS, well, what's the host name for my topology -vip? And the DNS will just serve it the next Binlog server or the next one or what have you until the slave is able to connect to some Binlog server and continue replicating from the exact same point. So this is like the second nice thing about Binlog servers. I talked about the fan out, and now there's also the failover, right? The high availability. Binlog servers are a very thin layer. They don't do much of a job. They just copy paste binary logs. They allow login from slaves and they serve them the binary logs. But other than that, they're not writing data. All your inserts and deletes, etc. Nothing's going on there. It's not even a black hole. There's nothing. Nothing is being executed on them. No parsing. Not anything. So they're very lightweight. We use the smallest machines we have for Binlog servers. No problem. They can take the load. They're not really doing much, and yet they provide. They provide it with high resilience to failure. Compared to some intermediate master that dies, well, we have a solution for that as well. We use sudo gdid to recover from an intermediate master, and yet it requires some work. Like, okay, let's investigate the binary logs. It's cool. It's super cool. I love it. I invented it. Yay, great. But Binlog servers make that much easier. Right? You don't need to do the math. You can just move stuff around, and you don't care. You connect to this one, to this server, to that server, and you don't care. So one of the nice things is that Jean-François, my colleague, has invented the Binlog server and is leading the vision of what he wants to achieve, and our group with Simon J. Mudd, we're benchmarking and testing and providing feedback, and it's still evolving, and we're kind of shaping this into where we want this to go. And we're also writing Orchestrator, which is the tool that maintains or manages the topology of Binlog servers. And so Orchestrator, well, if you haven't used Orchestrator as yet, you can move slaves around, make some slaves replicate from other slaves, change your topologies, recover, do crash recoveries, etc. And one of the latest additions to Orchestrator is support for Binlog servers. So if I take that slave and it replicates from this Binlog server, and I say, okay, let's move that one up, then Orchestrator understands, wait, that slave replicates from Binlog server, therefore, to move that one level up, I don't need to do any calculation. I just need to change the host name, the change master to master host equals, and I'm keeping the log file and log number as they were. There's no need to do anything about it. Even if we weren't using VIPs, which we do, but even if we weren't, I would be able to now log into that machine. Someone wrote that I should kill -9 during this presentation, but I don't think I'm going to do that today. I could log into this machine and kill the process, shut down the machine, whatever. And Orchestrator would know how to fail over slaves of a Binlog server. So it would realize that, oh, wait, this instance is down, it's dead, and there were two slaves that were hanging below that instance. Now, what can I do with those slaves? One of the options is to use sudo gdid and say, okay, I'm going to take those slaves and connect them to that master or here or what have you, by comparing entries in the binary logs and matching up, coordinating the two until they're right at the exact position and start replication, and we're happy. But with Binlog servers, it's even easier. When Orchestrator sees such a case that this server is dead, it says, well, okay, it's a Binlog server. For sure, I can move those two slaves up one level to replicate from the master without doing any math. Now, I can do that for sure, but maybe there is a better plan. And since Orchestrator investigates your topology and it crawls your topology and it keeps a state of your topology, right? It doesn't learn your topology and forgets about it. It keeps a state. It knows how it should look like, what it looked like a minute ago. So when that server dies, Orchestrator recalls that, wait, it had a sibling, and that sibling was also a binlog server. Now, two binlog servers replicating from the same master, all three of them are serving the exact same binlogs at the exact file, at the exact position. I may just as well move these two under that binlog server and get on with it. And I don't want to burden the master. Who knows? Maybe it's having hard time. It's not easy being serving requests, whatever. I'm just going to relay those. I'm just going to use that binlog server, the sibling of the dead one, as the new parent, as a new master of those two slaves. Questions so far? Wow, I've talked a lot. So I've got a lot more to talk about. So questions so far?
Yeah, actually, I have one, Shlomi. So with binlog servers, so in this orchestrator interface right now, you show that they have inherit, so that you know that they are effectively servicing the same data as the upstream master.
True.
So I'm assuming that means, one, it's got the same server ID going into statements it's moving along?
True.
Okay. And then as a client, how do you know that it's a binlog server versus an actual MySQL-D? Does it have something different in the version message, or?
Right. So yes, exactly so. So far, I haven't spoken about the implementation of the binlog server, and I'm following Jean-François' vision. Like, if you've been to his presentation in Procon Live, like he talked about 40 minutes. It was pure math, right? There was no implementation. So down to implementation. Our current implementation of binlog server is through MaxScale. There's a plugin to MaxScale called the binlog server. It's not yet in stable release. We're using right now. We're testing and evaluating two versions. It's 1.10, 1.19, and we're hoping to see a stable release shortly. The MaxScale binlog server accepts normal client connections, so you can use MySQL-H hostname of binlog server using whatever username and password you already have on that topology. So the binlog server actually, when it connects to the master, it downloads the credentials, the credential table, and it provides you with the same grant system, the same grants as you would have on a normal MySQL. Once you're logged in, you're able to execute a limited set of commands. That's the current implementation, right? You can't show tables because there are no tables, but you can show slave status. You can stop slave, start slave. You can show variables. So some of these commands are really very limited. They've been tailored. How do you say in English? They were custom made for our requests. So it's just those commands that we feel are absolutely essential to make binlog server work. So right now it's a bit limited. Like you can show global variables like max scale, which is like all the variables. Like you will find the max scale version, stuff like that. Otherwise, you can query some other normal variables like select at version, select at host name, at server ID, stuff like that. You could, of course, show slave status, stop slave, start slave in recent versions of MaxScale, change master to, so stuff like that. So, of course, the select show global variables like MaxScale, %. That's your initial step to find out, am I talking to a binlog server?
Got it. Thank you. And I guess real quick, take a quick pause. We had two new people jump in that I'd like to introduce themselves real quick. So, John, do you want to go first?
Sure, thanks. I'm John Cesario. I'm a DBA at Square. It's been a while since I joined this panel, but I'm happy to be back on it. And looking forward to hearing more about Orchestrator, because I think Orchestrator is just one of the coolest products that has come out of the MySQL ecosystem the past couple of years, and definitely just excited to see where it goes and where we can take it as a community as well.
Okay, and Dan.
Hi, I'm Dan Post, a colleague of John's. Also really excited to see some of the developments in Orchestrator.
Okay, cool. Yeah, so any other questions, I guess, for Shlomi, now that he's turned off his screen share and is showing his beautiful face?
I've got more. I just wanted to let people ask away.
I think one of the questions that a lot of people are going to have, seeing Binlog servers in general, they definitely have some overlap in purpose with GTIDs, where do you feel they deliver more flexibility and more strength over GTIDs? And do you feel like there's any that there is overlap, and how do they compare?
Yes, so there are. Yes, there's no overlap. There's advantages to both sides, and I can definitely see some advantages to using Binlog servers. One of them is the ease and speed at which you can reheal or fix topologies, like I've shown. Like an intermediate master dies, and you want to connect the slave of the slave, with the master using GD80. That's fine, that works, but it involves scanning the binary logs of both. Like, there's some work involved. If you have to salvage 10 slaves, there's going to be 10 times that work, because MySQL is unaware that those 10 slaves are all siblings. You will have to connect them one by one. That will take time. Whereas in Binlog servers, it's just change master 2, the same master host. You don't need to do the math. The master host, the same Binlog file, the same Binlog positions. That's one. The other thing is that the Binlog server, like I said, it's not busy. It's not really doing much. Whereas with an intermediate master, well, it's a slave that also has to write all that data, so it's working as hard as any slave, and it's serving more slaves. So you see it a lot. Like intermediate masters happen to lag, and everything behind them lags as well. The 5.6 implementation of Oracle GDIDs require you to have log slave updates on all your servers, so it's an additional I/O, etc. With Binlog servers, the Binlog servers themselves do the equivalent of log slave updates, but otherwise your slaves don't need to have binary logs enabled at all if you don't want them to. So in that respect, it's more. Recovery of that master is slightly more complex, but we have it figured out by now, and we're hoping that this will actually work quite shortly. Well, we really need to get Jean-François. I spoke with him. He couldn't make it for tonight, but he showed me, like, on his spare time before he goes to sleep, he has these dreams of crazy topologies with Binlog servers, and he has some really, really interesting ideas about working out multiple masters, like multi-master replication with Binlog servers, and showing how you can avoid like pitfalls that you have today using like complex star topologies, etc. It's a bit like if you think about Tungsten Replicator. When Tungsten Replicator came out, whoa, now you can do star topologies and replicate everything to everything. It's a little bit like that with Binlog server, only Tungsten has all these wisdom of how the protocol works and how to to relay stuff, to how to invoke the Binlog entries on the slaves, etc. Whereas the Binlog servers, they just serve the binary logs, and yet if you have the proper filtering on Binlog servers, they can do like really interesting stuff. And I think it's I think the mere fact that it's very simple to explain what Binlog server is and show that it actually works using standard MySQL. There's nothing special about the MySQL involved. They don't need to know anything, and yet Binlog server doesn't need to be all that smart, and yet you get all these advantages. That calls for, it's a nice mathematical theory that we are yet to see where it goes to. And there's Jean-François. He's here.
Oh, cool.
So it looks like Jean-François is not completely on just yet. But so another question I did have, though, when you have binlog servers in the topology to help facilitate all this kind of stuff, so typically when you do intermediate masters in the topology, you accept that you're going to have additional replication lag, especially on downstream replicas. So 3 or 4 layers down, lag might be noticeably higher. So how often does that happen with binlog servers? Like how much additional replication lag is introduced by having them in the topology?
So right now on our production topologies, we don't see lags. So we only measure lags at 1 second resolution, right? But this is quite obvious. We don't get additional lags from the binlog servers unless there's a network issue, of course. But I don't know that there's ever been an additional lag because of 2 layers of binlog servers, and I don't expect there to be. If you're if you're using row-based replication and now you're purging 1 million rows, then that's going to create a lag because those entries will have to transfer across the wire. But that's still way faster than what it would take on an intermediate master.
Yeah. So Jean-François, you want to introduce yourself real quick?
I just heard my name. I don't have a lot of time, so I'm Jean-François Gagné. I work at Booking.com with Shlomi, and Shlomi mentioned my name a few times in the last 5 minutes. I decided, okay, I'll join 15 minutes and I can answer a few questions.
But you have this genie who tells you whenever your name is being mentioned in YouTube?
Exactly. I just finished running. I arrived home and I'm going to eat, and I have some friends here, so I don't have a lot of time this evening. But I say, okay, I can join 15 minutes and answer a few questions.
Okay, so actually, does anyone have questions for Jean-François while he's here? Dan, John?
Well, I can jump in, and like Shlomi was asking how like that the failover is a little trickier with binlog servers than with GTID. And well, I actually think it's more simple, but it's a different kind of, it's a different point of view. So in classic master failover, you just find the slave which is the most up to date, and then this is your candidate master. And in the binlog server world, you don't need to look for a slave. It's the binlog server that are holding the binlogs, and it's actually instead of adapting the slave, all the slaves to the new master, you actually adapt the new master to what is on the binlog server. So if you take a slave and you put it up at the top, you just need to put it at binlog n+1 from the binlog that are in the binlog server. Because let's say the binlog server is at binlog 150. The master dies. Eventually, all the binlog server will be at binlog 150 because you'll be able to chain and make them converge. So you only need to put the new master at the top, that is at binlog 151, and then the binlog server will happily continue replicating. So it's kind of a change in paradigm. Instead of adapting all the slaves to the new master, you adapt the new master to what is saved in the binlog server. So and in a way, I think it's a little more simple than touching a lot of slaves, especially at Booking.com, where we have tens of slaves. There's one trick, though, is your slave have binlog enabled, but not log slave updated. So they will always be at the binlog number lower than your master, because the master, you can do a few flush log and they'll be ahead of all your slave. And because your slave are not writing binlogs, they will always be behind on the binlog number. So the trick is to do a few flush logs or flush master or binary log on your slaves to put it at on the candidate master to put it at the top. And so this is kind of a trick, and I'm hoping that there will be a new functionality in MySQL to do reset master at, where doing a reset master at the binlog number, that will allow me to put a slave up at the right binlog without doing a flush log trick. So we'll see how things go there. If it gets into 5.7, I would really like it to get into 5.7, but I don't control that.
Okay, yeah, and actually Daniel just gave us 2 links to bug reports around. I just lost it. Around adding a reset master to X for binlog file. Do you want to talk about that a little bit, Daniel?
Yeah, that actually implements the thing JF was talking about. And I wrote a patch which allows you to do a reset master to, reset master at, and then specify the next binlog number. So that helps if you want to put a master on top of your binlog server, and make sure it starts at the next binlog position, at the next file.
Okay, cool. All right, so any other questions from folks, or should we let Shlomi kind of keep rolling with what he's got?
Yeah, so let me keep rolling. So I've shown like a very limited part of the binlog server. So right now I'm showing you a sample topology where the binlog servers don't actually replicate from the master, they replicate from some intermediate master. And yet, let us continue our exploration of what can go wrong, and slowly we'll migrate to the idea of how does that look like when everything is a binlog server. So again, we have that intermediate master and those couple of binlog servers. What happens, we've already discussed what happens if that binlog server dies. We say, okay, we take these two, we can either put them under the master or under the other binlog server. What happens if that intermediate master dies? This is like one of the great questions about GDID, pseudo GDID, replication in general, right? How do you coordinate the slaves, the orphans of the dead master or the dead intermediate master? Well, with GDID, you find the most up-to-date slave and you put all the other slaves beneath it. This requires some math because the slaves needs to understand how to connect to the most up-to-date slave. You need to figure out how MySQL needs to figure out how to do that. But then they all converge in a similar manner, but much simpler. Again, you pick up, okay, that one died, and those two, you know, they've been orphaned at different positions because they're like in different data centers or whatever, right? The network was not the same. They've managed to salvage different parts of the binary log. One of them is more up to date than the other, and that's easy to check because you show slave status on both, and they will both replicate from the same master. It's easy to do that math. And once you figure out what's the most up-to-date binlog server, let's say it's that one, right? You can just as easily take that one and make it a slave of that binlog server, and you just change master to the same master host. Change the master host, but the same master log file, the same master, the same position. And then again, you didn't have to do any math. And those two slaves you get for free, still replicating from that is now replicating from that. But of course, we're still hanging, like that master died, what do we do now? So let's now move on, and I'll explain a bit what Jean-François was talking about when he discussed failover of a master. So we've already got that like 50% through in some of our very large topologies, that we have a master, a normal master, and then a layer of Binlog servers. We've got otherwise some normal slaves, but we've got like a very big layer of Binlog servers, and in fact we're having this new data center where this will be the standard way of doing stuff, right? There's not going to be an intermediate master. We're going to just build a layer of Binlog servers. So imagine that one, and I don't know, let's pseudo GDID to the rescue. Let's imagine that we have a normal master and then just a layer of 3 Binlog servers, and all the rest is replicating from those Binlog servers. What does that provide us with? Well, the first thing, of course, is that the master is very relaxed because it's only serving binary logs like to what it thinks are 3 slaves, and those 3 slaves are in fact Binlog servers who are serving dozens and hundreds or whatever other Binlog slaves. So let's imagine that these 3 slaves are Binlog servers, 2 in one DC, 1 in another DC. Any one of them, I remind, can die, and it's very easy for us to migrate their slaves elsewhere. Now, what happens if the master dies? Visually showing what Jean-François meant is that we pick the most up-to-date Binlog server, let's say it's that one, and we move all the other Binlog servers underneath that one, right? So we put this one here, and we put this one here, and we make everyone converge by merely pointing them. Those slaves keep replicating from their Binlog servers by merely placing those Binlog servers under the most advanced one. We make the entire topology converge. Some of the slaves may lag, of course, but right, the master crashed. It's going to take a couple seconds till everything is figured out. At that time, we actually expect most, if not all, of the slaves to converge to the same point. But even if not all of them converge, so let's put this one over here, and we keep imagining right now that these 3 are Binlog servers, right? They're not, but we can pretend. So what we have now is the most up-to-date Binlog server, a dead master, right? This one is dead. We assume it's dead. We have that one as the most up-to-date Binlog server, and by nature of replication, all those slaves, some of them Binlog servers themselves, are converged to the exact same position of that Binlog server. And more, just think one step further. Not only are all of them at the exact same position, they also have the exact same master coordinates, because everyone is replicating either directly from the Binlog server or from a Binlog server that replicates from that Binlog server. And no matter how deep you go, they all think they have the same master at the same master log file at the same Binlog position, right? There's a beauty to that. And now the tricky part that Jean-François discussed is to say, okay, then one of those slaves is going to be the new master, and what we're going to do is like pick one of those that is, you know, up to date, and put it here instead of the master, and ask the Binlog server to replicate from that. In order to do that, you know, the Binlog server doesn't really replicate. You can't just point it to a different server and expect it to keep on running, because all it does is copy and paste in binary logs, and it needs, you know, if you change a master, it needs to have the same binary logs at the same positions, etc., right? It needs to be able to follow up copying the same series of binary logs. So the trick, the idea is that in order to fail over a master, so this master died, we decided that, okay, all the slaves converge, or some of them converge, we take the most up-to-date, and it's a good machine, and we're happy to promote it. what we do is that we flash master logs on that slave until the number of the binary log file resembles the one of the master at the point of death, +1. And we tell that binlog server, this one, to replicate from that slave, and we say, okay, now connect to that slave, and just change the host, but use the same binlog file coordinates. Now, those coordinates will be, I'm making this short, you'll have to purge the binary logs before that one, etc. But the binlog server will try to connect to that slave. It will notice that, oh, okay, something went wrong. There was seemingly a crash. I don't see the binlog file in position exactly there, but I'm going to roll forward one binlog file. Just so the binlog file 000123 is not there anymore or is truncated. I'm going to try 000124, and that's where the fun begins. We rolled the number here to 124, and this turns to master, and it's now accepting traffic. And the binlog server just keeps on replicating from 124, and everyone else is happy to keep on replicating from what they think is the same master, moving on with the same sequence of binary logs at the same sequence of positions. They just they all of them flushed logs at the exact same time. That's what they all see. They don't even recognize that there's a new master. So that's the idea about failing over a master with binlog server. More to come. So are there any questions so far?
I have an open-ended question for Shlomi and/or Jean-François.
Yeah.
So I'm actually really a big fan of the architecture of Binlog Server. I think about it as kind of a fabric that centralizes a lot of the needs mature organizations have of MySQL. I noticed, for instance, Brady is working on a semi-sync extension to Binlog Server. What are your experiences and thoughts around things like semi-sync and backup compression and some of the other things that can just be consolidated into this architecture?
JF, why don't you go ahead?
Yeah, I will take this one. So I'm planning to extend the Binlog server to implement the semi-sync protocol, and it also in a deployment like Booking.com where we have many slaves. I think it will be much more simple to think about only adding 6 Binlog server, let's say 2 per DC with 3 DCs, 6 Binlog server that are talking semi-sync with the master instead of let's say 20 slaves per DC. And so it is in my plans to go there. So to implement the semi-sync protocol in the Binlog server. And in that type of deployment, it is the Binlog server that acknowledges that now it has the Binlog locally. So at this point, we can guarantee that the Binlog is saved somewhere else. And in a way, a Binlog server is really, we can think about this as a copy of the Binlog and kind of a copy of the master from the slave point of view, because the slave consumes the Binlog. So a Binlog server is just a replica of the master serving Binlog. So it can basically do what you might want to do. And my best has already. So that was the thing ringing behind me. So I don't know if this answers the question. But it will not be ready in next month, but I'm planning to work on that this fall.
Yeah, it's definitely really exciting. Have you done any experiments with, I saw some presentations from a major social networker about backup compression through RBR analysis. It seems like that would fit very naturally into something like a binlog server that can store centrally a massive log of binlogs for the last month or something like that. I mean, it just seems like a really great central point for a lot of the peripheral needs that we have out of MySQL.
Yeah, well, there's About binlog compression, so it is a subject that is coming often. There was a few mail last week on the mailing list, and a binlog server could allow a lot of experimentation around binlog compression. We can think about deploying a binlog server on the master, and to deploy a binlog server on every slave, and then binlog server talk to binlog server, but you implement a different protocol there, maybe something that compress the binlog efficiently, but that is not bound to MySQL. So it would allow people to experiment with different compression algorithm and things like that just by playing with the binlog server. But from the point of view of the master, it only adds slave that talks the MySQL protocol, and the slave are still talking with local binlog server that also talk the MySQL protocol. So it can allow us to experiment with a lot of things. But I haven't done anything there. If anybody wants to do something there, I would be interested to give them my ideas. But there's a lot of things to do there. We could think about that through a WAN as an example to compress things or do other things. We could think about multicast also in that architecture to save bandwidth. But like, sky is the limit. Just think about your use case and imagine fit it to your architecture.
Really cool. So I wanted to go back, Shalomi, when you were talking about, you have a bad master and promoting things around, and I just want to make sure I understand this correctly. So after you've got the whole topology kind of caught up off of what the most up-to-date binlog server had, and you want to promote a replica, you said you just currently you issue a bunch of flush logs until the binary positions are kind of in the same spot, because you can't really like repoint a binary log server, I guess, at a new thing at that point.
Yeah, so the idea is, let's say the master was at binlog 00123, right? And like in theory, the slaves are they're not doing log slave updates. And in theory, let's agree for the moment, and we'll improve this, right? Let's agree that they all started with binlog 00001. So in order for a slave to be promoted to a master, it must first get to the state of having binlog 00123, or rather 124. So until such time that we have reset master 2 or reset master at some binlog name, we're now at the position of flushing 123 times the binary log so that it gets to number 00124.
Okay, that's very interesting.
Right. So that's a bit crazy, right? You don't want to do that at the time of the master failover, because, well, rotating 100 or thousands or tens of thousands of binary logs is crazy. And so the idea is different. The idea is periodically, like every minute, every 5 minutes, every 10 minutes, make sure through crontab, through what have you, make sure to rotate the slave's binary logs so that they're a few steps behind the master. So if the master is now at 123, make sure all the slaves are at 120. All right. So at the right time, at the moment you need to fail over, you only need to do like 3 or 4 flushes to get to the right position.
Okay, that makes more sense. Yeah, because just looking at our architecture and our topologies that we have here, and especially since we run master-master setup, it's very common that, so we have log slave updates running on everything at all times. And in our case, it's very common that, positions are going to be all over the place. It usually depends on what's the newest replica that's been built in a given cluster, would probably be the most behind. But okay, that's a pretty interesting case. So definitely, now the reset master to X position, like that really makes sense now.
And if by mistake some slave has a more up-to-date binlog server, binlog file name, you can either flush on the master a few times to make the master more advanced, or you could reset master on the slave and at your leisure bring it up to speed. Those are all options.
Okay, that makes sense. Yeah.
Just one complement to that. Repointing a binlog server is kind of, it's not hard, but it has an assumption that the binlog server continue to download what it has and what makes sense for it. So if it's at binlog number 10, it doesn't make sense to download binlog number 5 again. Or if it's at binlog number 10, it doesn't make sense to download binlog number 20 because there would be a gap. On the binlog server, if you have a crash at binlog number 10, your master is at binlog number 10, you want your next binlog on the binlog server to be binlog 11. So binlog number 1 to binlog number 10 is your old master, and binlog number 11 and 12, 13 will be the new master. And then when you put a new master at the top, you will have a few binlogs, a few binlog files after that will be from the other master. So the binlogs on the binlog server is continuous. There's no gap, and there's no translation layer. A slave with log slave update is translating a binlog position from the master to a binlog position in its binlog, but there's no such mapping on a binlog server. Well, there's a one-to-one mapping. It's exactly the binlog from the master. This is the way I think about that.
Yeah, and exactly that. Like you said, it's an assumption that it's just more. I look at it as it's the gotcha you need to remember, and it makes sense in the context of how this whole kind of thing operates. And then once the notion of reset master comes in, like, it makes this even easier. And so I guess in your guys' case, you probably have some sort of automated, when you do the failover. So you're using Orchestrator, I assume, but yeah, checks and balances kind of automatically happen to make sure you're not accidentally repointing the wrong thing at the wrong place. Actually, and maybe that's a good question. If I have a passive replica or a replica somewhere in my topology that I want to point my binlog server at, and its binary log file is actually lower than what the old master would be, does the binlog server throw an error? Does it not fail to replicate in that kind of situation?
Yes. So go ahead.
It doesn't make really any sense for a binlog server to point. Changing, there's only two operations that make sense repointing a binlog server. Either you repoint at the position where you are, so basically chaining binlog server is in that logic, or you rotate to the next binlog. But those are the two only things that make sense. Well, maybe there's a third one, which is initializing a binlog server, so it's starting downloading the binlog from master at position number, let's say, 100. So there's only those three things that make sense. Setting a different binlog name or a different position doesn't make sense for a binlog server.
Yeah, totally agreed. I'm literally getting at this is a human error situation, and would the binlog server protect you from making a mistake like that?
And yeah, but also just to clarify, because you hinted as much, we actually don't have the massive failover with binlog servers yet in production, so we don't know to tell you, all the use cases, all the scenarios. We're not doing this yet in production. And this leads me, I need 2 or 3 more minutes to. This nicely leads me to my next and last issue. So if you've been to Santa Clara, I was talking about how we do sudo grid in Booking.com, and Jean-François was talking about how we do binlog servers at Booking.com, and to some extent, those two compete against each other, right? Those two, they have a lot of overlap. Those are two techniques of healing topologies or scaling topologies or whatever, right? Or fixing broken topologies. And actually, one of the nicest parts right now is using both at the same time. And this is actually a necessity, because we don't just modify all our topologies at once to use everything in binlog servers, right? We try to do that gradually. And so we're in a state where we have like a master, a couple normal slaves, and then like one or two or more max scale Binlog servers. And what do we do now as the master dies? We're not in this world, and we're not in that world, right? We're in between worlds right now. We can't do, you know, the futuristic master promotion I've just discussed. It can't work like we've just described, because we have normal slaves. And then again, you know, if we just do sudo GDID or GDID like calculation, what happens to the max scale Binlog server? So right now, there's a hybrid solution through Orchestrator that says, oh, okay, we've got these two and the Binlog server. Let's assume for a moment that this is a Binlog server. Let's see who is the most up-to-date. If the most up-to-date server is the Binlog servers, let's put these two underneath, let them converge, and then extract them and move using sudo-gid or whatever all those slaves, you know, onto those servers, and then promote one and make it master. But if those two are more up to date than the Binlog server, then we can directly use sudo-gid to move those under those servers. And so, like, the introduction of sudo-gid is actually also solving the migration, you know, or the transition into Binlog servers. So that's like a fun development in the last month that I'm very happy about. And that's all I have to talk about for today.
Okay. And actually, with that, I think we are just about out of time. So I guess we'll just open up for a last round of questions from anybody, and then all.
Well, if there's no question, I'll just add a compliment. Binlog server replacing intermediate master has also bring interesting things to the table in parallel replication world, like MariaDB 10.0 and MySQL 5.7. I cannot give all the details, but intermediate master with parallel replication, well, an intermediate master will slow down parallel replication. You will lose parallelism with intermediate master because of rewriting the binlog with log slave update. And the binlog server allows to bypass that, because every slave is replicating from the binlog server. So there's not only failover and scaling, there's also the new goodies that are coming in MariaDB 10.0 and MySQL 5.7 that will be even like that. We must remove intermediate master to really take advantage of those. I can give you a link to discuss that. I've blogged about that on blog.booking.com in March or at the beginning of the year.
Okay, cool. Yeah, definitely send me the link, and I'll put it into the show notes. Okay, I guess actually with that, we're pretty much out of time, so I'll do a quick solicit for topics for next time. If there's anything people want to talk about more in depth next time, I guess we'll carry over orchestration versus configuration management to the next session we do. But anything else that folks would want to talk about? Dan, John, since you guys are, well, Dan, since you're new, I'd love to hear if there's anything in specific you want to talk about or discuss with a larger group of people. And John, since you haven't been here in a while, same goes for you.
Yeah, nothing off the top of my head, but I will definitely think about that.
Okay.
I am always interested in more Orchestrator.
Okay. I'm sure we can get Shlomi to keep talking about Orchestrator forever. And likewise, we can get Jean-Francois to always talk about binlog servers. So, all right. Well, I guess on that note, we're a wrap for this week. So thanks very much for everyone who made it. Shlomi, thanks for the presentation. Jean-Francois, thanks for your expertise and knowledge about this. And Daniel, as always, thanks for all the bug links and small links about fixes that are happening along the way. And we'll see everybody in 2 weeks, I think. Sound good?
You guys.
Take care, guys.
Thank you. Bye.